Hi everyone, welcome back to the channel. So today we are going to discuss artificial intelligence Turing machine, that is a very important topic for all computer science students. In this video we will cover the introduction to Turing machine as well as its important characteristics. So now let's just start this session. So at first you should know the developer of Turing machine. So it was introduced by a British mathematician named Alan Turing in 1936. इन्हीं के नाम पर इस मशीन का नाम ट्यूरिंग मशीन रखा गया था. It is basically a theoretical computational device that laid the foundation of modern computer science and the concept of algorithmic computation. We can also say it as कि Turing machine serves as a foundational concept in computer science and is used to understand the limits of what can be computed. What can be computed. The Turing machine is not a physical machine. Remember this point. It is not at all a physical machine that you all are imagining, but it is an abstract model. It is an abstract model that demonstrates how any algorithm or computational process can be carried out in a step-by-step manner. Its developer, Alan Turing, designed this machine to formalize the concept. It was designed to formalize the concept of computation, enabling mathematicians and computer scientists to analyze which problems can be solved algorithmically and which cannot. So this is a very, very important statement. I am repeating it. Okay. So Alan Turing designed this particular abstract model or this machine to formalize the concept of computation in the field of computer science, enabling mathematicians and computer scientists to analyze which problems can be solved algorithmically, कि कौन सी प्रॉब्लम्स को हम एल्गोरिथम्स के साथ सॉल्व कर सकते हैं और कौन सी प्रॉब्लम्स को सॉल्व नहीं कर सकते. Even though we can say modern computers are much more complex than Turing machines and they operate on the same basic principle. So this is the introduction to Turing machine. Now let's just talk about its characteristics. So first characteristic we have is infinite tape. Another is read write head. We will discuss everything in detail. Okay. So first is your infinite tape. The Turing machine operates on an infinite tape divided into cells. It contains one infinite tape. In simple terms, we can say a Turing machine has a tape that is infinite in both directions. And this tape can act as both the input and the memory. All right. So Turing machine operates on an infinite tape and this particular tape is divided into small cells. Each cell can contain one symbol. Each cell can contain one symbol from a finite set, that is usually including a blank symbol. We can also say the tape serves both input and memory, representing the machine's working storage. It serves as input and memory, okay, that representing machine's working storage. All right. Another characteristic is its read-write head. Simply, we can say the read-write head as a head in Turing machine. All right. Head. This particular head moves along the tape. It moves along the tape and read or write symbols. And a set of rules is also included here. All right, the machine has read-write head that moves along with the tape one cell at a time. It moves one cell of tape at a time. So this particular thing is very, very important. It can either read the symbol in the current cell or it can write a new symbol based on the machine's instructions. Also, the head can move either left or right, which allow the machine to modify the content of tape as it processes the input. So I hope everything is clear till now. The next point we have is finite state machine. The machine operates based on a finite set of states. At any given time, the machine is in one specific state. एक समय पे मशीन जो है किसी एक पर्टिकुलर स्टेट पर ही सेट रहती है. The transition from one state to another is determined by a transition function. It can be determined by its transition function, which is a set of rules that defines the machine's behavior. We can also say the transition function here in finite set machine, it dictates what symbol to write and which direction the head should move. All right. Next point we have is deterministic behavior of Turing machine. A standard Turing machine is deterministic. This particular thing is the major functionality of Turing machine. इसके basis पर ये काम करता है. Always a standard Turing machine. If we talk about a standard Turing machine, it is always deterministic. That means for any given state, deterministic behavior means for any given state and symbol read, there is exactly one defined action. There is exactly one defined action. The one defined action can be your write action, move action, change the state of your machine action. This deterministic nature ensures that the machine behaves predictably according to its rules. Another can be your halting condition. The Turing machine may eventually reach a point where no further moves are specified by the transition function, and this is what it halts. I am repeating the statement because it is very, very important. So halting condition means it signifies that the machine has completed its computation. In some cases, the machine may not halt and could run indefinitely if the problem is undecidable. All right. Next point we have is universality. Universality, sorry. Okay. So universality means what? We can say it as Universal Turing Machine. UTM. Universal Turing Machine. Simple Turing Machine can also sometimes known as Universal Turing Machine, that is related to universality. Turing showed that there is a special kind of Turing machine that is called Universal Turing Machine, which can simulate any other Turing machine. It is a universal Turing machine that can easily simulate any other general Turing machine. This means that universal Turing machine can be programmed to take as input a description of any other Turing machine and its input, and then it simulates the behavior of that machine. All right, so this is called universality. Another point can be your decidability. Okay, it always explores the concept of decidability, which refers to whether a problem can be solved by computational algorithms, Some problems are decidable, meaning they can be solved by Turing machine in a finite number of steps, while some problems are also undecidable, that is halting problem. Halting problem is your undecidable problem and other problems are decidable problems. Undecidable problem means No algorithm can determine the solution of all the possible inputs. That is the undecidable problem. The last characteristic we have is its abstract nature. ठीक है? Turing machine is also called abstract mathematical model, and it is not designed to be a physically built. I have told you earlier, Turing machine is not at all a physical machine. It is just an abstract model, right? So it is abstract in nature. It is a powerful enough to represent the fundamental capabilities of any modern computer. And the simplicity of Turing machine allow it to represent any computational process, which is why it is often used in theoretical computer science to provide the capabilities and limits the computation. So this is very important statement कि Turing machine is not at all a physical machine. It is just an abstract model that can be used for computational processes. So I hope students everything is clear to you. If you have any doubt, you can comment below, and thank you so much.